Welcome back to Smart Architectural Programming, and also welcome back if you're following along our accompanying videos on our Introduction to Java book. And in this particular video, we're starting off with chapter 3, and more particularly, we're looking into operators and casting in Java. Two fundamental topics that every Java programmer needs to master and have a command of. So without further ado, let's push right into it. So first, as we start off, like with everything, we need to understand what are operators. Operators, quite simply, are special symbols that perform special functions on variables and values. We've already discussed what variables are. They're store of values. So operator is a special symbol that actually acts on that variable, and with the action of acting on that variable, it results in a new value basically, or a new result. And how does that happen, right? The question is, how does that happen? You've probably heard of addition, subtraction. It's just like that. So we have an addition symbol or a subtraction symbol, and we're able to do that action of addition or subtraction using that symbol on two variables and their values. We also need to further remember that Java has several categories of operators, including arithmetic, relational, logical, bitwise, and assignment operators basically. So we're probably going to go over each of these operators and how they look in our coding environment and explain them through that. And that is how we're going to go over all of these operators, whether they're arithmetic, relational, logical, bitwise, or assignment operators or others basically. So first thing that we need to go over are arithmetic operators. As you can see on the screen right now, that arithmetic operators are simple mathematical operators that you've seen or used in your mathematics courses basically. So it has addition, subtraction, multiplication, division, and modulus. Arithmetic operators are straightforward and simple to understand. You know what addition does, you know what subtraction does, you know what multiplication does, you know what division does. And modulus is slightly unique in a programming context in the sense that if you divide a certain value, it gives you the remainder of that value basically. So if I have 12 divided by 5, the remainder 5 2 is the 10, and 2 is the remainder value basically, right? And you can see how these operators act and their outputs on the screen right now. We have two values a and b on line 2, and these are acting on the operator, and you can see the output right next to each of the lines. So that is how you can understand how these operators work, arithmetic operators work, and their effects on variables. So let's move on to something a little more not common, like relational operators, right? So to be honest, they're very common as well. They tell you the relation between different operators, right? Two values, right? So we have alligator mouths, two assignment operators, and exclamation mark assignment operator on line 5. So how it works is the operator on line 2 is basically is asking, wherever the alligator mouth point is open toward, that is the bigger value compared to the other one. So here 2 is asking, is a bigger than b? And based on the value we saw previously of a and b, which is 10 and 5, a is bigger than b, so that's true. Similarly, we reverse the alligator mouth and ask if b is greater than a on line 3, and that's false because a is greater than b. Similarly, we have two assignment operators which checks whether a value is equal to each other. So 5, if we had both a and b were 5 on line 4, that would be true, but since they're not the same value, the answer is going to be false. And on the 5, we see an exclamation mark and assignment operator which says that a and b are not equal to each other, and that's true because 10 and 5 are not equivalent values. Relational operators generally return Boolean values true and false, and they help us in decision making statements like if-else conditions and so on and so forth in programming. So this is an important aspect to programmers and using and understanding how relational operators can be used in decision making aspects of programming. Then we have logical and bitwise operators, right? So let's focus on logical operators first. They allow us to combine multiple conditions and check them all together. As you can see here, we have we have on line 2 a Boolean variable called x that with a value of true, and a Boolean operator y with a value of false. So logical operators check onto these Boolean values to a large degree. So we're checking if x and we have two ampersand symbols on line 3, that means that x and y must be true, right? If both the values are like this. So it's false because y is false, and hence it's going to be false. Similarly, line 4, we have two horizontal bars, which basically is the OR symbol. What it means is either x or y must be true. As x is true, the value is going to be true, as you can see. And line 5, we have exclamation mark x. What it means is whatever the value of x is, flip that, right? And that's for not. So it basically is a not operator. It means that the value must be the opposite of what it is right now. Now that we are done with logical operators, let's move to the bitwise operators. Basically, bitwise operators I'm going to touch very, very briefly. They work on binary values, and they are the same as the previous one, logical operators. We discussed their AND, or XOR symbols onto them, and they work in binary operations. I'm not going to go deep into binary operations, but it's good at this stage to understand there's something called bitwise operations that work on binary operations, and just let's leave it at that. So now that we have covered operators, we need to understand typecasting. Converting one data type into another is a very, very important concept to understand, because a lot of data must be converted into other data types while you're working on them. So there are two types of casting that we need to understand: implicit casting and explicit casting, basically. Let's focus on that. So with implicit casting, you can see in the screen here that an int is automatically converted into a double on line 3, and Java does know this safely because there's no data loss. But what if we need to convert a double into an int? That's where explicit casting comes in. So you need to understand here that implicitly, if we convert an int into a double, it doesn't change anything, because int is just smaller form of a double. Double has double the capacity of storing values, right? It includes the values that could be stored in int, but a double value has values that an int can't store. So we need explicit casting to convert a double to into an int. As you can see below, we have a double value 9.78 on line 7, and we have an int that does explicit casting to convert my double into an int. So and when we do that, you'll notice that 9.78 becomes 9. So ultimately what you see here is that when narrowing data types, we must use explicit casting, or Java will throw an error. Be cautious, because this can lead to loss of precision, and precision is very, very important in certain softwares. So let's wrap up our video. Basically, we've covered operators and typecasting in Java in this particular chapter, first video of chapter 3. Essential concepts. These are essential concepts for writing efficient code. If you found this video helpful, give it a thumbs up, and subscribe to Smart Architectural Program, and hit the bell icon so you don't miss the next lesson. And if you're following along the accompanying videos on the book, remember, you've started chapter 3 and you have completed the first video of chapter 3, moving ahead into your journey to learn Java and become a good programmer in Java. With that, I'm going to wrap up and see you in our next video.